Hi, I'm Neel.
Hi, I'm Alisen.
For part A, this is our circuit. For R1, we have a 22 kilo ohm resistor, and for R2, we have two resistors in parallel, the 22 kilo ohm and the 38 kilo ohm, which forms a 14 kilo ohm resistance equivalent. We have a potentiometer RL of 2.5 kilo ohms, and our VC is 10.62 volts, and our VE is 4.21 volts. This is our second circuit, and R1 and R2 are both 22 kilo ohms. For our first data point, we shorted the potentiometer and got VE equals to 1.68. For our second data point, we set RL to 250 ohms, and we measure across here for VC, and we get 0.42 volts, and for VE we get 1.68 volts.
Here is our voltage amplifier circuit using the transistor. Because we don't have a 2 kilo ohm resistor, we used a 1 kilo ohm and a 1 kilo ohm in parallel, and then for the emitter resistor, it's 1 kilo ohms. When we measure the voltage at the collector versus Vin, you can see that we get an inverted but amplified signal. This makes sense since if we increase the base voltage slightly, we get an increased emitter current. As a result of that, we get an increased collector current because IC is approximately equal to IE. When we increase the base voltage, we get a corresponding increase at VE because V gamma is constant for the transistor. When we plug this in and solve for the emitter current, we get an increase, and this therefore corresponds to an increase in the collector current. When we use Ohm's law, we can derive that VC of t is equal to VC minus RC over RE times the change, or delta. Because RC is 2 kilo ohms and RE is 1 kilo ohms, we get an inverting amplification of 2. Therefore, this explains why our VC is simply inverted and amplified compared to Vn. When we look at the network sweep, you can see that the gain decreases as we go to higher and higher frequencies. This is because the internal junction capacitors within the transistor. When we look at the phase, it starts at 180 degrees because this is inverting, but then as we go to higher and higher frequencies, this decreases. This is due to the delayed response from the transistor. Therefore, an increase in the base voltage causes an increase in the emitter current, but the increase in the collector current is a little delayed.